Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface, and so far we have looked at how to access the fields of an object, a Java object, and how to get it or set it in C++, and then we looked at how to invoke a method or call a method of a Java object in C++ using JNI. Now obviously the last step is to see how we can actually instantiate an object in C++ and return it back to Java. And we know that in Java, for example, look at this person class that we have. We construct an object using the constructor, right? And constructor is nothing but a special method. It's just a special method, and it's a method that in the bytecode it actually gets a special name, which is init, which stands for initialization, right? And these diamond brackets are in fact part of the name of the constructor name. So init inside the diamond brackets. So constructor is nothing but a special method of a class, right? And one of the important things about the constructor is that it can never be a static. It's never a static method, right? It doesn't have a static call. Secondly, its return type is always void. So it always has a void signature, and its name is always init because it's a special method, and its name is always init inside these diamond brackets. So once you understand this, the rest is the same as calling a method. In order to construct an object in C++ using JNI, we have to call a special method inside the class that has the name init inside these diamond brackets, and then just like calling a method, we have to provide the signature of the method and its return type. And constructor is a special method, and its return type is always void. All right, and the constructor is never static. So when we get the method ID of this constructor, because again this is a method, a special method, the name is init in the bytecode. When we get the method ID, we should always use the get method ID. We never use the get static method ID because constructor is not a static call. All right, so again, if we want to instantiate an object of type person in C++, we have to first get the JClass metadata, a pointer that points to the metadata of this person class. So we ask JVM to find the class on the class path, and returns a JClass object, which is a pointer to the basically class object on the Java heap. And then we get the J method ID. The name of the method must always be init inside these diamond brackets, and we provide the signature of the method, so the signature of the parameters that go inside the constructor. But the return type must always be void. All right, so this is very similar how we invoke an instance method, a method of a instance method, a non-static method of a object. And after we do that, we ask the JVM to, so we have two options: either use the new object method that is inside the JVM functions, or we can just use the call method, right? Call void method, because and okay, one more thing is that constructor always returns an object. It must return an object, right? Because we are constructing. Although the return type is void, in the signature it has to return a J object back. So when we invoke this new object and we pass a J class reference, because again we cannot pass there is no instance of a J object, that it's just J class. We have to pass a reference to the class. J method ID is the method ID of the constructor, which has the name init, and return type is void. And we have to pass the actual value of the arguments. In this case, it's going to be a J string that represents a Java string, and a J int that represents a Java integer. And then this new object call returns a J object, and we typically don't need to do any typecasting. For example, if this is a Java string, and we want to invoke the constructor of the string class, then it still returns a J object. In that case, we can actually cast it to a J string, but there is really no need for that. All right, so I hope you understand how this instantiating of an object works in C++. Basically, we have to just call a special method inside the class, which is the init method the signature of the return type is void. All right, and then we call the new object method from JVM, and we ask JVM to construct a new object, and this always returns a J object, right? Unlike a method, a regular method, that if we call it, if the return type is void, it doesn't return anything. But this new object, the constructor, the signature of the return type is void, but it does, in fact, it returns a J object. All right. And again, constructor that never has a static call, so we always use the get method ID, not get a static method ID. We don't use the get static method ID. All right. So let's head to Eclipse and try to construct a person object in C++ and send it back to Java. So if I go to Eclipse, I already have created a package called test15, and inside this package I have created this person object that has a string name and age. These are instance fields that are associated with the state of this object, and I have a constructor that takes a string and an integer and constructs the object, and then I have a toString method. Now the first thing that I'm going to do, I'm going to the bytecode view, click on the constructor and look at the signature of the constructor. So if I zoom in again, so you see in the bytecode the name of the constructor is always a special method called init, and these diamond brackets, less than and greater than equals symbols, these are part of the name of the method. So init in these diamond brackets, this is the name of the constructor method, right, in the bytecode. And then here it takes two parameters. One is L java/lang/string semicolon, which means the first parameter is a string Java object. The second one is I, which means it's a primitive integer. And the return type of a constructor of this special init method, it's always void. All right. And then as you can see, the JVM has a implicit call to the init method inside the object, and again, init means invoking the constructor. That's the name of the constructor inside the bytecode. And again, the object constructor, the constructor inside the object class, it doesn't take any parameters, and the return type is always void for the constructor. And you see the bytecode instruction is invoke special, so this is a special method inside the class. It has a special name and the return type is special. It's always void. But we know that when we call this, we actually construct an object and it returns a pointer or reference to an object. But in the signature, in the bytecode signature, the return type is always void. All right. Now knowing this, let's create a new class to test this. So test constructor call, and let's have a main method here. And in the main method, I am going to create test1. And maybe it's also good to also try to use reflection API inside the Java to see how we can construct an object using reflection API. So public static void test1. And in test1, I'm going to just use Java reflection API. So just like the field and method that we need to get an identifier to them, we need to get a constructor of type person, right? Capital type person. Let's call this constructor. So let's import this constructor object from Java lang reflect. So we get the person class, capital P, dot class. So this returns a class that has the meta information about this person class. And then we say get declared constructor, and then we have to specify the parameter type or the meta information about the parameters. So we know that this person constructor, it only has one constructor, and that constructor takes a string. So a string dot class, this is the meta information about the string, and the integer, a primitive integer, so int dot class. And again, even the primitive types have a class associated with them. So we have in the meta space, we have information about the integers also. So this throws some exceptions. One of them is no such method exception. And you see again, we are getting the information about the constructor, but it throws an exception about the method. And that's because constructor is just a method, but it's a special method. And we have the same security exception. So we get a constructor object, and it's parameterized over the type of the object or the type of the class, which is person. And this constructor provides information about and access to a single constructor for a class, right? So now that we have this, what should we do? We have to use it and say new instance. And then now we have to actually provide the actual arguments, the values of this string and int. So let's say Bob. So this is the string, and then 21 is for the integer, right? And this also throws exception, instantiation exception, illegal access exception, illegal argument exception, invocation target exception. So that's a lot of exceptions, and let's just throw them out of the main for now. All right. So when we call this new instance method, this returns an object, a Java object. And because the constructor is parameterized type, this doesn't really return an object. It actually knows the type, so it returns a person object. So person equals new person. All right. And so this is different from the methods, because in the methods or in the fields, if you recall, if I had a field ID and invoke get on it, it always returned an object. I had to manually typecast it. But here for the constructor, because it's parameterized over the type of the class, we don't need it. It directly returns the correct type or correct class, right? So this person is not an object. The return of this new instance is actually a person. And then I can do a sysout on this person. So I'm using reflection API to actually construct an object. So let's see. And as you can see, we have this person, name is Bob, and age is 21. All right. All right. So now let's try to do this in C++. So let's try to create a person object in C++ and send it back to Java. So public static void public static native person. Now we are creating a person. Create person, and again we have to provide the parameters, a string name and int age. And I'm going to have a test2 method, public static void test2, and here I'm just saying that person is create person, the name is James C++, and the age is 31, and I'll do a sysout on the person. Perfect. So we have everything ready. We have our native method, and this native method is supposed to take a Java string and a Java int primitive, and then it's supposed to go inside this person class and call this constructor, which is again a special method, and then return a J object back to us, and we send that J object to Java, and the JVM already knows that J object should be converted to a person object. So JVM automatically does that, which is very good. So you already know the routine. So I go to C++ perspective, I click on this Java file that has the native method and run the Java H tool on it, and it creates the header file. So it was in the test15 package here, and it creates the header file, this function prototype for create person. And then I go to a source folder and then create a new .cpp file. Let's call it a constructor, call constructor.cpp. And then the very first thing that we do, we include the header file that we just created, test15, and then we copy and paste this function prototype into our CPP, and then start providing a body. So JNI environment, let's call it JVM or ENV. I guess both of them are common terms. I think JVM is more clear here because we say that, okay, it's the JVM that does the stuff for us. J class is a reference to the calling class because this was a static method. J string is the name parameter, and J int is age. All right. So what do we need to do? We need to, in a step one, remember we want to create a person object, so we have to call a special method, which is the constructor inside the person class. So first we have to get a hold of the meta information of this person class. So we want a J class of person, right? J class person class is JVM please find this class on the class path. It's in the test 15 package, and the name is person, and returns a pointer to the meta information, to the class file on the meta space that holds the information about the class. And this expression is equivalent to basically doing this person.class in Java, because this returns a class file, a class object that has the meta information about the person class, right? So we get this J class, and in step 2, now we have to call the constructor, right? Call constructor, and it's just a special method. It's a method, so it's like any other method. So we need to get a hold of method ID for constructor. So basically, constructor ID is, again, we ask our JVM get method ID. And again, constructor is a special method that is never static, so the call to the constructor is always non-static. That's why we're not using get static method ID. We're using just get method ID. We have to pass the person class, J class, and then the name of the method for the constructor and the signature. So here's where the difference between the constructor call and another method inside the person class call comes from. The name of the method, because constructor is a special method, the name is always init inside these diamond brackets. All right, this is how JVM handles the constructor calls. And regardless of the type of the parameters that we pass to the constructor, the return type always has a void signature. And again, this is another difference. So the name is always special. So what is the signature of parameters? It's a string and an integer, right? So L semicolon and then I. L semicolon signifies we are passing a Java object. And what is that Java object? Java object is Java/lang/string. So we provide the class path description of that object inside L semicolon. All right, so it takes a L Java/lang/string semicolon and an integer. The return type is always void. The name is init inside these diamond brackets. Now that we have this method ID for the constructor, step 3, we create new object, right? Create new object. So again, we ask our JVM to please create a new object. Just like a new double array or whatever that JVM created for us in the past, now it's creating a new object for us. And again, we need to pass a reference of the J class. What kind of class? We have to provide the meta information and the method ID, so constructor ID, because we want to invoke the constructor. And then there is another vararg, right, that we actually provide the actual values for this constructor call. And the first parameter is name, which is a J string. The second one is age, which is a JInt, which directly maps to int on my machine. And this new object returns a J object, right? So J object, person object is this. Now we created this person, and let's just return it back to the Java. So person object. And again, there is no typecasting here. Because this function, even though in Java it expects a person object, in C++ we are creating a J object, and we sending it back as a J object to Java. And JVM automatically looks at the J class reference, and it knows that it should be a person. It's equivalent to this parameterization, right? Now basically JVM has a hold of the meta information which is inside this J class. So it knows that this constructor call is creating a person object. So it has to return a person object to us. So let's compile this. It compiles fine. Let's copy and paste our dynamic library to Java project. And let's go back here and run test 2. And it throws an unsatisfied link error because we need to also load the dynamic library. System load library, and the name is native_c. And let's run it one more time. And now we have our person object created, James C++ and age 31. All right. So what we did, we send the Java string and Java integer to C++, and in C++ we created a person object and send it back to Java, right? And then we did a sysout on the person, which automatically invokes the toString method that we had already implemented. Now what happens if we have multiple constructors? There is no problem with that. So let's set a default value for age, which is 21. And what we can do here is that basically if I basically go here and if I now say that, okay, this doesn't take an integer, it only takes a Java string, and again the return type is still void, the name is still init because it's a special method inside the class, and now I don't specify the age, I just say name, right? So let's compile again, copy and paste the dynamic library, and then run my Java. And as you can see, the age gets its default value, even though we are passing 31. In the C++, we're not using this age parameter. We are actually calling the constructor that only takes a string parameter. And then the age gets the default value of 21. The name gets the value of whatever we are sending to C++. All right. So there is another thing is that as I mentioned, one way to creating the object is new object function for this JVM pointer, which is I always recommend to use this one. But again, constructor, we're just getting a method ID, right? So we should in theory be able to do the same thing that we do when we call a regular method. So let's say JVM call basically void method. Now the difference here is that this void method, the return type is void, but that's not what we want, right? We want to get a J object out of it. So call object method. So let's see if this works. So we pass in the J object, but again we don't have a J object, right? Because constructor is a special kind of method, right? We don't pass a reference of the object to it. So let's see what else we have. Call basically object method, and then all of these object methods, they take a J object reference, which we don't have. And then I guess call object method, we can perhaps we can just pass a dummy object. I guess the object doesn't matter in this case. J class is the person class, the method ID is constructor ID, and then we also have a vararg, which is, let's say it's just name. So this object, I guess if we just set it to null pointer, let's see if this works. And this should return a J object, person obj. So basically I'm saying that call this object method, and all right, so let's try one more time. JVM call object method, and we pass a basically so for object method we have to pass a reference to the object. So let's see if this works. So if I pass a null pointer and then the method ID, constructor ID, let's see what happens. If I compile this compiles fine. If I copy and paste these to Java and then run this test, let's see if this can be successful. So we get a null pointer exception, so this doesn't work. Call object method doesn't work, we cannot pass a null pointer. And then let's see what else we can do. So we need to call something that call some sort of method that can return us a J object. So call object method, right? And apparently passing the method ID alone doesn't help, so we have to somehow pass a J class reference too. So call method, call object method did not work, and then call a static object method. Let's try to see if this works. So we pass in a person class constructor, and then we just send the value of the name to it. So let's run this. The compilation is done. Let's copy and paste to Java and see if this works. And the JVM crashes, so that doesn't work either. So let's see what else we can do. So call non-virtual object method. So non-virtual object method, and then we can let's try this one. So we pass a null pointer, and then the J class person class method ID constructor ID, we pass the name, and then let's compile again, and let's copy and paste, and let's run our Java. It still says null pointer exception, so let's just I don't know, send something like 0, and then copy and paste the dynamic library to Java, and then run it. Null pointer exception. So yeah, so I guess it's not, I guess the best way is just to use the new object call, and this just automatically takes a reference to the Java class, and then the method ID which is corresponding to the constructor, and again the name should always be init inside these diamond brackets, and the return type should always be void. And constructor overloading, basically we specify which constructor to call by specifying the signature of the parameters that we specify in this method signature, right? So if I add integer, then I'm saying that, okay, call this constructor. JVM understands that it has to call a constructor that takes a string and integer. If I say that the signature is only basically a string, then JVM automatically assumes that it means I'm asking it to call this constructor that only takes a string, right? Now obviously if I say call that constructor and provide two arguments, name and age, here the JVM, I guess it will throw an exception. Let's see what happens. So we are asking it to call this constructor, and then we are providing the parameter values for these constructors. So let's see what happens. I guess the JVM can understand it, so there is no problem about it, because in the vararg the first one is still age. So let's double check that, and then go here and run this. Yeah, it still works fine. So JVM takes the first argument and then neglects the second one. But if I say age and name, this doesn't work, because now JVM takes the first one and it assumes it to be a string, but it's not. So JVM will complain or crash in this case. Let's see. Let's run the Java program. Yes, the JVM crashed. So yeah, here we have to specify the string name first. And if we provide other parameters, it basically ignores them, because it expects only one parameter of type Java string or JString. So compile this again, copy and paste to our Java project, and then run the Java test. Yes, this works. So this is very easy, and I hope it's easy for you to understand this. And calling the constructor is basically the same as calling a method. So you have to get the method ID with the understanding that the constructor is a special method. It has a special name init inside the diamond brackets. The return type is always void. And then you have to use the new object function inside the JVM, right? To construct a J object. The type doesn't matter. If you send it back to Java, JVM automatically knows that it should the type of this J object. In this case, it's person. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.